Okay, so just like the last problem, we're going to ignore the green one for now. We're going to find the area of the purple triangle. I already know my basic area formula is area equals 1/2 times the base times the height. That's my standard triangle area formula. I've been using that for years and years and years. Now, on this problem, the area is going to equal 1/2 the base. How big is the base?
15.
I think most people would agree that it's 15 times the height. But the height is missing, right?
Yes.
The height is missing. So I'm going to have to fill in that height in just a minute. Now, in order to find the height, I know the height is located right here. So I'm going to draw that in. I know that all heights are always perpendicular to the base. The height is always perpendicular to the base. Always. And this is my height now, right? So now how can I use trigonometry to help me find the height?
Is that an L?
It's supposed to be an H. I'm going to use the sine, right? So I'm going to come over here. I don't know where I have room for this. I'll come down here. I'm going to do the sine of 40 degrees equals h over 10. Is that okay? And then, of course, to solve that, you just multiply by 10. So I multiply both sides by 10. And my height is going to be whatever 10 times the sine of 40 is. And that goes in my calculator, right? Okay. Now, you're telling me that that's about 6.4. And then, of course, I would take the 6.4 and plug it in here and then finish my formula. But I don't want to do that because I want to do something different with the green triangle. So instead, what I'm going to do is instead of putting that in my calculator, I'm just going to take 10 sine 40. Instead of putting it in my calculator and getting 6 point whatever, I'm just going to put in 10 sine 40. So is it fair to say that the area of my triangle is 1/2 times 15 times 10 sine 40? Will that give me the area of the triangle? Yeah. Yes. Now, of course, that's a ugly answer, and I would rather just put it in my calculator. But I wanted to do that because I actually want to take the green triangle, which is identical to the purple triangle, and I want to find the area again. So even though I would normally put this in my calculator, instead what I'm going to do is I'm going to go down and I'm going to look at the green. So we're going to look at the green triangle now. And my directions are the same. I want to find the area of the green triangle. So once again, the formula for the area of a triangle is area equals 1/2 base times height. Do you know the base? What is the base? Okay, it's just a B. On my green triangle, it's just a B right now. And the height is going to be represented by, it's not there yet, right? So I'm going to have to draw it in. So I draw in my height. I know my height is always perpendicular, so I make sure it's perpendicular. And now how do you find the height? Okay, that's going to be sine of angle A. Now on the last problem it was 40, but now it's just going to be the sine of angle A equals h over c. And again, just to make sure you know what I'm looking at triangle A, B, well, there's no letter down here, but it's this orange triangle. Okay? I guess I could call that a D. A, B, D. All right? So I'm right here. I'm trying to solve for my height. How do you get the height by itself? Times it by the C. So my height is going to equal C sine A. Whatever the C is, times the sine of A. Now I want you to plug that in up here. And we're going to write that down as 1/2 times B times C sine A. And what you've just done is you've just created a formula that will work for the area of any triangle. So it's a new area formula. Okay? Now, the old one, 1/2 base times height, yeah, that still totally works. It still works all the time. It still works when you know the base and the height. But guess what? I did not know the height on this problem. And oftentimes, you do not know the height. But I did know this side and this side and the angle that was in between those two. And that's the formula that we're going to write down. All right? So if you've got that, we'll write down the formula. I'm going to write down that these three formulas are the same formula from the perspective of angle A and perspective of angle B and this perspective of angle C. It's always that the area equals the side times another side times the sine of the included angle. That's really what these three formulas are trying to tell you. Included means the angle in between. So, side C and side B has angle A in between them. Side B and side A has C in between it. That's the included angle. And of course the other one would be these two have this angle in between it. So really, guys, that's what these three formulas say, just in their own way. Now, how does it work on this particular triangle? Well, this one is labeled A, B, and C. You know what we need to identify, though? I don't know if you noticed, but little a is always across from big A. Little b is across from big B, and little c is across from little c. So if I look at my triangle down here, little a is located down here in between C and B. Little b is located up here, and little c is located over here. Now, I really am just trying to use my formula. So I want to check things out. Okay. Do I know both of these sides? No, I don't. So it doesn't do me any good to use the formula with the sine of C. Do I know both of these sides? No. So it doesn't do me any good to use the formula with the B. Which formula should I be using? I should be using this formula, and that's the one I'm going to use. So all you do is simply write down our new area formula, 1/2 BC sine A, and then you fill in the blanks. 1/2, my B is 6, my C is 3, times the sine of angle A, which is 25 degrees. And that's just going straight to your calculator, and I heard 3.8. All right, 3.8 centimeters squared. Okay? Guys, that's the fastest way of doing problems like this. Notice this was not long and hard. This was one formula, one substitution, and one go to your calculator. Pretty straightforward, right? Now, I could have done this problem without this formula, but it would have been longer. And it would have been a little bit more tedious, and I could have made a right triangle. And I do want to do that for us as soon as everybody's caught up here. So, if I were going to look through this, all right, and I were going to do this same problem this time without using that formula, I would need to know 1/2 the base times the height, my standard old regular triangle formula. Okay? Now, the problem is, this one is very hard to see what's the base and the height. Most people would say CB is the base, but I don't know it. And the height, most people might say, goes right here. But you know what? I don't know that either. So this way is not a good way of doing it. Instead, what I can do is I can take this triangle and basically flip it upside down. And my height will be from B to here. And now, do you see this little triangle right here? Use that little triangle to find the height. So that would be, let's see, the H is across from the 25, so that's opposite. 3 is the hypotenuse, so what's opposite in hypotenuse? Sine. Sine of 25 degrees equals H over 3. Multiply both sides by 3. And you just found out that the height is whatever 3 sine 25 is, right? And somebody go ahead and give that to me. What is it? 1.3. Okay? Well, once you know the height, you can plug that in your formula. So I would have 1/2 times the base. I just found out the height is 1.3, but you know what? Which one's the base? It's the 6. That's right, because remember, the height has to be perpendicular to the base. So if we determine that this is the height, 6 must be the base. So I need 1/2 times 6 times 1.3. And I should get the same thing I got on the last one. Was it 3.9? Okay. So do you see you can do it either way? It's your choice which way you want to do that. As I want you to notice that we are no longer talking about a right triangle, are we? This is a regular old anything triangle. I do not have to have a right triangle to use the law of sine. You have to have a right triangle to use opposite over hypotenuse. Adjacent over hypotenuse, opposite over adjacent. You must have a right triangle. But to use this one, I don't. So that opens this possibility up to any triangle in the world. And we're going to look and see how it works. Okay? I want you, again, you can read page 833 for that proof, but I'm not going to go over it in any more detail. Let's look at this blue triangle here. And let's figure out what it is, how we can use this formula. Yes, ma'am. I'm going to label all the pieces. Little p is going to be on the opposite side of big P, so it goes here. Little n is going to be opposite of the big N, so it goes here. And little q is opposite of big Q, so it goes here. All right. Now, all I'm going to do is I'm going to write down my law of sines, but this time using P's and Q's and such. So it's going to be the sine of angle P over little p equals the sine of angle Q. Oh, I don't want Q actually. I want to do N first. N over little n, which also has to equal the sine of angle Q over little q. Now, let's just start filling in the blanks of what we know. Do I know angle P? So I can say the sine of 42 degrees divided by little p. Do I know little p? No. So I'm just going to put little p. Has to equal the sine of angle N. Do I know the sine of angle N?
Yes.
Oh.
Oh, yeah, you do.
I could find it out very easily, couldn't I?
Yeah.
So even though they did not tell me, could I figure out angle N? What is it?
70. No, just kidding. Just kidding. Just kidding. I thought that was a 5.
It's going to be 180 minus
35.
73.
73.
I said it. 73.
Wait. Yeah, 73.
All right.
It's your own fault.
It's going to be 73 degrees, right? It's 73 degrees. So even though they didn't give it to me, I am going to put that in there as 73 degrees. Divided by 5 because the n is 5. And then I've got the sine of Q. How big is Q? Okay, Q is 65 over little q. They didn't tell me little q, right? All right. Now, this looks like a whole complicated mess, but the reality is I've got 3 different fractions equal to each other. Now, I would ask you, how do you solve an equation with 2 equal signs? I don't know. But I do know how to solve one with 1 equal sign. Guys, what we have here are 3 different equations, and let me show you what they are. Knowing that I have 3 different equations, these 2, these two, and then these two. To help me find P, I'm going to just focus on these two right here. I've got sine of 42 over P equals sine of 73 over 5. Now that's a proportion. Do you recognize that? How do you solve proportions? You cross multiply. So let's cross multiply this. And we get
So you don't divide first?
P sine 73 equals 5 sine 42. Now, if you wanted to, could you put 5 sine 72 in your calculator right now?
Yes.
Yes, and it would give you a decimal answer, right? If you wanted to, you could do sine 73 in your calculator. But what I can also do to get P by itself is just do one more step, and that's divide both sides by sine 73. And that gives me what P is going to equal. P is going to equal whatever 5 times the sine of 42 is divided by the sine of 73. Somebody run that through your calculator. 5 times the sine of 42 divided by the sine of 73.
Does the sine of 73 just go under sine of 42 or sine of 42 times 5? 3.5.
Triangle. If my directions say solve the triangle, what do you think they want me to do?
Solve the triangle.
Find every angle and side. Every single angle, every single side. Well, you're right about that. The best way for me to handle this is I need to go ahead and I'm just going to write down every angle and every side and just kind of make a little list, a little checklist. So I need to know angle A, angle B, and angle C.
Is that L?
No, it's angle.
Oh.
And I also need to know side AB, side AC, and side BC. So those are all of the things that I need to know in order to solve the triangle. Fill in what you know. Fill in what was given. A, oh wait, we don't know A. We know B is 53. We know C is 100. And we know, let's see, what is that? AC is 9. Now that was the given information. Is there anything you could find quickly? All right, most of you see right now, you could find that this angle is 27, and I assume you did 180 minus 100 plus 53, right? Okay, so now we know angle A is 27. Now that wasn't given to me, I had to find it. Okay. Your answer is all of this. All right, so solve the triangle. Angle side situation is the best situation to use the law of sines in, so that's exactly where I'm going to start. I'm going to write down my sine. So that's sine A over A equals sine B over B and sine C over C. And then, of course, I'm just going to start filling in my blanks. So, the sine of angle A, what is my angle A? It's 27, we just found that. Over little a, which I don't know, has to equal the sine of angle B, which is 53 degrees, over little b, which is 9. That was given to us. Which equals the sine of angle C, which is 100, over little c, which I don't know. Now, I actually have two things I have to find, right? A and C. And remember, you have multiple equations up here. I'm going to use this one to find A. So to find A, I'm going to use this one, and I'll do it all in orange. I'm going to rewrite it, actually. Sine of 27 over A equals sine of 53 over 9. How do you solve this? You are going to cross multiply. Okay, so you are going to cross multiply. And that leaves me with A sine 53 equals 9 sine 27. Now remember, that could go in your calculator now, or you could do it later. How do you finish getting A by itself? Divide both sides by sine of 53. And that's going to leave me with my A. So someone in the calculator, give me 9 sine 27, all divided by sine 53. And you said it was? Thing, but this time, in order to find little c, use these two equations. So once again, I'm going to rewrite it. You don't necessarily have to, but I'm going to do sine of 53 over 9 has to equal sine of 100 over c. And you're going to cross multiply. And you're going to get 9 sine 100 equals c sine 53, whichever. Get c by itself, so we're going to divide by sine of 53. And if someone can help me in the calculator and tell me what is 9 times sine 100 divided by sine 53, it's 11.1. And that goes up here, 11.1. And we have determined our final answer is going to be all of these. That's our final answer. You had to know all 6 of them.